All right, let's talk about one of the toughest, most important challenges in software today. How in the world do you manage data when it's spread all over the place in a microservices architecture? Get this wrong, and your whole system can fall apart. So let's dive right in.
So, I'm going to start with a pretty bold statement here. It's something that a lot of us who build these systems have probably felt at some point, and it's this. Your microservices, they're built on a lie.
So, what's the lie? Well, it's this really tempting idea that we can just go off and build these beautiful, independent little services and kind of just hope the data underneath magically works itself out. But it doesn't. You can't ignore it. And today, we are going to face that reality and figure out how to untangle that mess.
Okay, let's kick things off with our first section, the distributed data dilemma. Because you have to understand, the second you decide to break up a big application into tiny services, you fundamentally change the entire game when it comes to your data.
You know, back in the monolith world, things were, well, simpler. We had one big, cozy database. We had these wonderful things called ACID transactions, which meant every operation was all or nothing, it was predictable, it was safe. But in the microservices world, we've got databases all over the place. And that simple guarantee of consistency, it's just gone. It's been replaced by this big question mark, this complex, distributed reality.
So how do we even begin to bring some sanity back into this new, complex world? Well, it all starts with one absolutely foundational principle. One service, one database.
This is rule number 1, the database per service pattern. It means exactly what it sounds like. Each microservice is the absolute king of its own data. It owns it, it manages it, and crucially, no other service is allowed to just reach in and mess with its database. This is totally non-negotiable if you want services that are actually independent.
And this image right here illustrates it perfectly. See how each service has its own little data world? We call that a bounded context. Think of it like a fortress wall. Inside that wall, the service makes all the rules for its data. If another service needs something, it can't just tunnel in. It has to politely knock on the front gate, the API. This right here is the bedrock of true service autonomy.
Okay, so we've put up our fortress walls, our services are independent, that's great. But we've just created a massive new headache. What happens when a single customer action needs to change data in multiple services at once? Welcome to the transaction conundrum.
Let's make this super real. Picture this. A customer clicks Buy. The order service dutifully creates a new order. The inventory service goes and reserves that item. But then, the payment service tries to charge the card, and it fails. Now what? If you don't have a plan for this, you end up in a complete mess. The order exists, but there's no money. The system is now in an inconsistent state. You have this ghost order floating around, an item is reserved that shouldn't be, and you've got a very confused and probably angry customer. This is the danger zone.
So, how do we clean up this disaster? The answer is an incredibly powerful pattern called a saga. Think of a saga as a workflow coordinator with a really good backup plan. It runs a series of separate local transactions, one in each service. But here's the magic. If any single step fails, the saga immediately triggers compensating transactions to go back and undo everything that already worked. It's like a multi-step undo button.
Okay, let's replay that exact same scenario, but this time a saga is in charge. The order service creates the order. The payment service fails. But this time, bam, the saga kicks in. It initiates a rollback. It tells the order service, hey, that thing you just did? Undo it. The order service then cancels the order, and the final result, a perfectly consistent state. No mess. The system has literally healed itself.
Now, for a saga to work its magic, all these different services need a way to talk to each other without being tangled up in a web of direct calls. And that brings us to our next big idea, talking through events. This is the heart of event-driven architecture. Just look at the difference here. On the left, you have that tangled mess of direct calls. It's brittle. Service A has to know about service B and C. If B changes, A might break. It's a nightmare. But on the right, it's so much cleaner. A service just publishes an event, like order was placed, and shouts it into the void. It has no idea who's listening, and it doesn't care. Other services can then choose to subscribe to that event and react. This is loose coupling, and it's the secret sauce for building systems that can actually scale and survive failures.
So this new world of sagas and events, it requires a pretty big mental shift from us. We have to let go of this deep-seated need for everything to be perfectly, instantly consistent across the entire system. We have to learn to embrace a new way of thinking.
Back with our monolith, we had those strict ACID guarantees. Think of a bank transfer. The money is instantly gone from one account and appears in the other. There's no in between. But in a distributed system, that's often too slow and rigid. Instead, we lean into base. This means our system is basically available. It might be in a temporary soft state for a moment, but it will be eventually consistent. Think about ordering from Amazon. You get the confirmation email instantly, but the inventory status might take a few seconds to update everywhere. The system isn't perfectly in sync for a brief moment, but it all catches up. We're trading that instant perfection for a system that's faster and more resilient.
And that word I just used, trade, that is the key to all of this. Being a good software architect isn't about finding some magical, perfect solution. It never is. It's about deeply understanding and then consciously choosing the right set of compromises for the job.
I really want this quote to stick with you. The authors of the source material call it the first law of software architecture. Everything is a trade-off. And if you ever find a solution that you think has no downsides, it almost certainly just means you haven't figured out what you're giving up yet.
So let's just recap the big trade-offs we've talked about. We're trading the beautiful simplicity of the monolith for the massive scalability of microservices. We're trading that instant, perfect consistency for a system that's always online. By giving each service its own database, we trade a single familiar tool for what's called polyglot persistence, which is just a fancy way of saying we get the freedom to pick the absolute perfect database for every single job. And we trade top-down central control for empowering our teams with more autonomy. At the end of the day, the question you should be asking isn't, what's the best architecture, because there's no such thing. The real question, the one you have to answer as an engineer, is this. Now that you know the patterns and you understand the consequences, which trade-offs are you going to choose?